Okay, the next speaker is Robinett, Alpha India 6 Victor November.
Thank you.
And Rob is going to talk about creating a low-cost, high-performance FST4W whisper beacon site using the RFzero or QRP Labs QDX.
Thank you for your patience. Sorry, we have computer incompatibility problems. So my talk is to complement what Nigel and Gwynn have presented. And the point is, as they mentioned before, there are thousands of whisper transmitters and receivers in the world today. And this is a page that is created by Arnie. I don't know if Arnie, are you here? Okay. A hero in our group is Arnie has created a number of Grafana pages that allow us to visualize the whisper and now the FST4W data sets. And this is one of his pages, which summarizes the activity, I think, over the last 24 hours. I took this a day or two ago. But it shows the activity, the number of spots that are being recorded, and up in this corner, you can see there's 2404 transmitters worldwide, whisper transmitters and 4W transmitters, and 1,289 receive sites that reported spots during that 24-hour period. Interestingly, let me go back here for a second. Interestingly, I don't know if you who are involved in whisper might have noticed that back about a week ago, there was a 4.5-hour gap where whispernet.org was no longer available. Oh, I guess I could show you. Let's see, which one? That one? Yeah, right here. And you can see that when the whispernet.org server went down, they lost power, okay, in the building. That all of the WSJT-x clients could no longer, no clients could upload spots during that time. So you can see that the total spot count dropped for this brief period of time. And one of the characteristics of the WSJT-x is that if it fails to upload your spots, it throws them away. So you lose that data. Now, the software that we've mentioned, wsprdaemon, the software that I've created with help from others, caches the spots. So I think that during this period, all of these spots were cached and uploaded once this WhisperNet server returned. So this event, and this is a kind of an aside for this talk, but this event shows the importance of having very robust systems, or you're going to lose data. And specifically, as I'll discuss later in my talk, one of the important events, there are some unique events that are going to be occurring in the coming year where we do not want to lose the data because we'll never be able to get it back. And this has to do with the upcoming eclipses. But let me go on and talk about, these are the whisper data. There's, on contrast, there's very few sites transmitting and receiving 4W. Arnie's page allows us to select for the type of packet, and we can see here that over that same 24-hour period, there were only 25 different transmitters out of the 2,800. So only 1% of the transmitting sites were running FST4W transmitting. And similarly, although not as importantly in a way, there were only 38 receive sites that were listening for and reporting the 4W packets. And this is understandable. One can understand why people don't transmit or receive 4W, because you have to have, if you switch your receive site or switch your WSJT-x to 4W mode, you're going to lose a bunch of capabilities. You're not going to see, transmit, be heard by, or hear any whisper packets. So to switch from whisper mode to 4W mode will produce, you'll see far fewer, your signals will be heard, you will hear many fewer signals, and you will be heard by many fewer people. So one of the features that we've been working on to make 4W more accessible was enhancements that I introduced over a year ago to the to my wsprdaemon program. And in these enhancements allow a site to listen to all the modes simultaneously. So you can take one receive channel, and of course my stuff really only works with the Kiwi at the moment, but you can take one receive channel and decode all of the modes without at the same time. I mean, so at minute 2, you would decode the WSPR2 and the FST4s, okay, from one receive channel on your Kiwi. At minute 5, you would pick up the 5-minute long packet that started at time 0. At minute 4, well, you would again get, at minute 4, you get, and so on. So one of my goals was to lower the barriers to the adoption, widespread adoption of 4W by making sites running my wsprdaemon program, allowing them to listen simultaneously and report all the different potential modes. Now, this is more CPU intensive, of course, on the receive side, because we're now decoding multiple times, the multiple modes at the same time. And of course, as you process longer and longer WSPR or 4W modes, it takes longer and longer, much more CPU time. 15 times the CPU time to decode a 30-minute long WSPR 4W 1800 packet. But we have actually installed this software at there's about 45 sites worldwide that are now listening for 4W. And most of them are listening at least for the 120, the 2 minutes, and the 5-minute long packets, as well as the WSPR, regular WSPR packets. So if you're starting to, if you're interested in contributing to this, and putting up a 4W transmitter, there are people listening for you. And right now, they're about to, perhaps most of the sites that are reporting are in North America, unfortunately. I mean, we have a site in Tasmania, Phil, VK4JJ, who operates the WSPR Live WSPR report site. I don't know what's there it goes. Okay, yes, I know I'm talking too long. Well, in any case, the receive issue is, I won't say totally solved. I want to encourage anyone who has Kiwis to modify them. It's you can easily modify a Kiwi by, as you can see here, I even did it with my limited soldering skills. You tack a SMA bulkhead with a little cable, and there's a pad that you can solder it to. And so this is all that's required. Well, of course, then you have to have an oscillator to drive it. A GPS, a Bogner is what I've been using. But this simple modification, there's a checkbox in the administrative page of the Kiwi, converts your Kiwi into a GPS disciplined oscillator. There are some further caveats. Before you go do it, there's some specifics that I'm not going to go into here, but it's really quite easy to do. And as a result, you will have add to the receive sites. And one of the reasons I came to this show is to encourage those of you here in Europe and elsewhere in the world to enhance your receive sites. If you're a wsprdaemon user, or if you have a Kiwi and want to use it, this is open source software. You'll find it on our wsprdaemon.org page, and we're happy to help you configure, install, and monitor your receive site. So that's the very brief summary of, please, we need more 4W receive sites. On the transmit side, there are really few transmitters. I mean, there are fewer significant sites than are listed up on that previous page. And, as you've seen, there are really very few. It's hard to dedicate even a high-end, especially a high-end transceiver, regular transceiver, dedicated to whisper transmission. It's just an unfortunate, it's just such an expensive and intrusive way and disruptive to the other operations. So many people have purchased and deployed dedicated whisper beacon transmitters. The Zacktek is a good example of an excellent product that is widely used. Unfortunately, although the Zacktek and others have a GPS section in them, that section is not used to discipline their transmit oscillator. And so there really needs to be some alternative solutions. And what I've found is, of course, Nigel presented the option of the QDX, and I don't know if any of you have physically seen a QDX, but this is one, a modified QDX. It has, in addition, it has an SMA connector on the back, and of course but it is a little, there's some problems with using the QDXs for this purpose, and one of them is that this requires WSJT-x to talk to it. And so, I have to have a Raspberry Pi or something on the side, which isn't a big deal. But there's another problem, which is that the WSJT-x software has a limited capability. You cannot schedule mode and band changes with WSJT-x when you are in 4W mode. So if you use this, you're really going to be transmitting and receiving on only one band, and that's an unfortunate constraint. I'm not aware if any of the newer versions of I think the JTX 2.7 is in beta. I'm not aware that they've included band changes in 4W mode. So while this is an excellent device and it has many strengths, I mean, it's 5 watts output, which is really, that's 13 dB more than 200 milliwatts from it. So you're going to see, with a 5-watt output device, you're going to see propagation events that you would not see with the Zacktek. So as you can see that the side scatter and other propagation events that Nigel and Gwynn have talked about are 20 or 30 dB lower than a direct path. So even if you have a strong single hop signal, strong would be 0 dB. When you go into these multi-hop and side scatters, your signal levels are going to drop by 30 dB perhaps, and may be undecodable, even though the signal is in fact would be receivable at higher power. So for our purposes, higher power is very helpful for understanding these new propagation modes that we're looking at. So that's a very good thing about the QDX, but like every engineering device, it has its pluses and minuses, and so it has its strengths and weaknesses. I have considered adding software to wsprdaemon, enhance it so that it can do the transmit as well as the receive feature, in which case we could at least address the band scanning, the lack of band scanning. wsprdaemon includes all kinds of band scanning options and mode switching, and we could include it. Maybe I'll do that. I mean, there's other projects for me. Ideally, we'd have something like for adopters who would like to put out 4W transmissions. Another option, and I think an excellent and interesting product that I was not aware of really until the last year, is Bo Hansen's RFzero. And this is a complete, well, it's much more than a whisper transmitter and a 4W transmitter, but it certainly can be used as such. And in fact, Bo has one of these units online. So this unit, you give it a GPS antenna signal, you give it 5 volts of power, and there's an SMA output connector to go to your antenna. and you configure it, you power it up, and it will do band scanning and go through this. It's a very flexible device. However, it's only 20 milliwatts of output power. And one would think 20 milliwatts, where can you go? Okay, but in fact, every week, Bo's transmissions are being received in Tasmania and in California. Okay, 20 milliwatts on 20 meters. So there's much useful information. If only to get on air quickly. One of these is, I don't know, 85 euros right now. He sells them from Denmark, which uses the kroner. But inexpensive, it's fully assembled. It's a wonderful introduction. It was a wonderful introduction for me to the Arduino and this whole world of programming, as well as the introduction to the 5351 clock chip, which is the core of this and many other high-performance receivers and transmitters. This device also can be used as a GPSDO, and you could feed the output of this into a Kiwi, a modified Kiwi. So this can be used for receive and for transmit. In fact, I think it's possible. And is Bo here? Did he? Bo, I think you can output two of the 53 outputs simultaneously. Would it be, so it would be possible to drive a QDX with 25 megahertz and to drive a Kiwi at 66 megahertz and have two disciplined devices from this one card. This probably is what I think. Both of these are useful. In some sense, they complement each other. There is Hans offers a QLG2, but I don't believe that the QLG2 is a fully disciplined oscillator. I think it's a referenced GPS reference signal, but this device is perhaps at gigahertz frequencies there might be some differences between the performance of this and a Bogner. But for us, our uses, these are really excellent devices. So I'd like to and very easy to use and fun for me. I found it very fun. So. Bo, I'm sure you could talk to, but here's an example. I spoke about how far Bo's signals are going. Here's VK7JJ. This is his transmit site, OZ2, OZ0RF, and you can see these lines show. Now this is signals going regularly into North America at 20 milliwatts of output, or roughly 20 milliwatts, right? But surprisingly down here to Tasmania, and probably many other places, but these are the only sites that are listening for 4W. Many of them are the only sites. So if we had more listening sites, we might learn more about the capabilities. I'm going to skip over the discussion of the QRP, the QDX. Nigel covered it briefly in more depth than I will do. But as you can see, there's the kit that's sold by Paul. A WB6CXC sells a kit that simplifies the modification of the QDX so I'm going to briefly. I have 1 minute until noon. But I just briefly wanted to talk about a third transmitter that we're developing. We're part of the HAMSci group in the United States that does citizen science investigations. And we have a major effort upcoming to study the effects on the ionosphere of these eclipses that are coming up. There's a annular eclipse, 95% coverage of the sun that occurs on October 13th of this year, and the path of that is that annularity is this direction. So in my case, my group of wsprdaemon users, a number of them, we're deploying ourselves, transmit and receive sites along this path. And by listening between them and the data from them to receive sites on both sides of them, we hope to gain new insights into the ionospheric behavior, the interaction between the sun and the F and E layers and so on. The unique thing about the eclipse is that, in contrast to sunrise and sunset, which happen every day, but are very gradual transitions, the eclipse is like ringing a bell on the ionosphere, and it's possible that the propagation measurements that we make may give us, and radio scientists, new insights into the interaction between solar weather and the Earth's ionosphere. So we're making a big effort to do that. But because the event lasts only for 4 minutes, the totality, well, at most is almost 5 minutes. If you want to gather data at, if you're using a standard QDX, you can only transmit on one frequency every 2 minutes. So that's going to limit your samples, to the frequencies of your samples. So what Paul has done, who makes that adapter kit, he has designed a simultaneous multiband 4W beacon. And this consists of a series of, there's a kind of an exciter, which is over here. The exciter uses the 5351s, one for each band, well, maybe one for each 2 bands, and then drives a little amplifier system that he's developed. Which is about a 1 watt output device. And for the simplicity, what we've tried to do is create it so that you could create one antenna. I mean, it is pretty easy to erect either a trap vertical or an end-fed half wave, 80-meter half wave, which will be resonant and a reasonably good transmitter on all the bands 80 through 10. Now, it's not possible to really manufacture using surface mount inductors. Can't really manufacture an all 8-band combiner. So his combiner is 4 bands. It will take an 80-meter signal, a 40-meter, 20-meter, and 10-meter, and combine them all together into one output to go to your end-fed multi-band antenna. There will be a couple of additional channels that could be connected to other dedicated antennas. So you could envision a site where you had a multi-band end-fed and a couple of dipoles, one for 15 and one for 17 or something like that, or 30 meters and 15 meters or whatever. So you could put up at least six bands, transmit 6 bands simultaneously every cycle for the duration of the event. And these components, Paul is beta testing them now, and they should be available for purchase through his Turn ILM Systems website in the near future. I don't know that he doesn't even know what the costs are. His motivation is to help accelerate the study of the ionosphere, not to make a lot of money. But of course, he doesn't want to lose money in the process. So if this interests you, not just for the eclipse event, but also for long-term studies, we hope to deploy systems in many parts of the world. As you can see from, let's see if I can bring this. No, it's not going to. No, it's not going to allow me to switch. But you can see that so much of the whisper transmissions and receptions occur within North America or within Europe or between North America and Europe. And there's so little coverage on the rest of the world. I would really hope that not only that other parts of the world, individuals who are going to other parts of the world, would consider establishing whisper, receive, and transmit sites. we believe that there's a whole gaps in our understanding of the ionosphere, in part because there's no signals out there. Nobody's. I mean, I can't find a whisper transmitter receiver in Tahiti or in French Oceania. If there's anyone from that region, establishing a whisper and 4W transmit and receive site in that area would be a great contribution to our ionospheric research. Similarly, there's barely any in South America. Africa is a dead zone. There's whole areas, especially the southern hemisphere, that have just no coverage in monitoring, and it would be a great contribution to science. Radio science if people were to establish those. I think I've gone over my issue, and so I stop there for now, but if you have any questions about this, please, I'll be here for the rest of the afternoon. I don't know if we have anyone who had questions online, and I'm certainly willing to stay and talk, but I'll try to, I hope you found that interesting and useful. Okay? Okay. Okay.
So,
do we have anything more? I'm done. You guys were distracted, so I'm done.
okay.
Sorry.
So, thank you very much.
Thank you very much. A very interesting work which he did the last time, and well, if somebody is here in the room who uses Whisper, everybody I think everybody knows Robinett because of his wsprdaemon work, and it is a great work since maybe 10 years or more.
No, I returned to amateur radio about 6 years ago, and entirely because I broke my leg. Sliding off the roof of a little shed in our Maui site. So that really put me in bed for about 6 months. And one of my oldest friends who had stayed in amateur radio said, geez, you're pretty well. I could scoot around and so on, but I was pretty limited in what I could do. He said, you might find ham radio really interesting. So he lent me his L-craft, and I fiddled with it a little bit, and I said, "Well, this is a really different hobby." It's so that led me back into it. And then my professional background is mostly in IT. I've been an entrepreneur and started a number of startups in the professional television broadcast equipment. Oh, yeah. And so my interest was was in monitoring, reliability, and so on. And I saw as I returned to ham, I saw the ham world. I saw my possibility, that I could contribute uniquely to apply my IT skills, my monitoring skills, and programming skills to the creation of the database. And thankfully, I've had the help of especially of Gwynn, joined me in this enterprise, and we've invested now years in developing the whole wsprdaemon system. It's not just the receive software that runs on your Raspberry Pi and Toxic, but we have a whole database that we maintain where the spots are recorded. And in contrast, WhisperNet only records a little bit of the data decoded, even by the Whisper decoder in JTX. Only some of the data is recorded. And for example, the Whisper decoder decodes to 1/10 of a hertz, 1/10 of a hertz frequency accuracy. But the WhisperNet database throws away that 1/10 of a hertz. So you can give them, your frequency, 1409.1 hertz in the band. It'll come back as 1409. Yeah. So that is the smallest enhancement that we've added. So we've created a database where we have where we put out enhanced spots. So those enhanced spots which we record include not only the full frequency accuracy, but in the case of the 4W packets, it includes the spectral spread information. We also record the background noise level. that was in two different ways. We measured the noise level in two different ways, and we record that background noise level along with the spots. So that background noise level allows us to infer the absolute signal levels, okay, which you don't get out of JTX. So our database has that additional capabilities, along with a whole bunch of others, and I ramble on, okay? But those are, if this interests you, there's a wsprdaemon, DAEMON, .org website, where we have links to all of these databases and the software, of course, to install, and some previous presentations on that we have made at other conferences earlier in our careers together. But we are finding, as we go deeper into the capabilities of this WSPR world, that there's a tremendous amount that can be learned there. And we have just begun to make some insights, these additional insights. So we hope what we're lacking the most, to get back to the subject, is we're lacking transmit sites. And if you put up a 4W transmitter, if there's propagation to one of our receive sites, your spots will be recorded.
Okay, fully agree.
Okay.
I think you have won a lot of new stations with operating FST4W. I think this is now everybody well known. Thank you very much for this.
Well, good. Well, okay. Anyway, I hope,
are there any
it's of interest to
questions
you.
In the audience actually now for Rob? We are running out of time into the noon.
There are no questions from the stream.
Yeah, there is a question. Moment. Hans, please.
Rob, thank you. Thank you for your presentation. On your last file, you showed this 8-band simultaneous transmitter, especially for these.
I'm sorry, I missed your question.
Event.
And my hearing is terrible, so I may have to get. You may have to.
It's now better?
We repeat, Hans, please.
Okay, it's now better. You can hear me now.
I'm sorry.
You can hear me now.
Yeah, I think we repeat the question. Yeah.
Okay.
You need to
Hans, please.
Yeah.
I have a simple question. You tried to transmit 8 bands at the same time during the eclipse. Do you expect some special information on the different bands, which is different?
We don't really.
What you see on 40 meter will be different on 20? Or why are you doing this 8-band simultaneous transmission?
We don't know. I mean,
okay,
we don't really know.
Trial.
I mean, it may be that we get no transmissions on 80 and 40 meters. We don't really, no one has. There's only been one attempt. There was an attempt previously in 2017, but I think a much more limited study that was done at that time. So this is genuinely new science. It hasn't been studied before. So until we actually go and make the measurements, there are theoretical models about how the ionosphere will behave during an eclipse, but there's been very little practical measurements in an attempt to match the measurements with the model that exists for the eclipse event. So, and the measurements my understanding is that measurements in the last eclipse suggest that there are some divergence between the model of how the solar weather interacts with the ionosphere. There are some variations, and that's a source of a great area of research. And this is academic research, not just hams doing this.
Okay.
These are scientists from MIT University and other places.
Thank you, Rob.
Okay, we have some more questions. Please, very short. We are running out of time now.
I try to be very short. You were mentioning hamsci.org, the ham science investigations with this mode.
Yeah.
This is mostly concentrated in America.
Well,
in the US, are you aware of some similar efforts in Europe?
Yes, I'm not aware of similar citizen science initiative here in Europe, but I certainly would. This is the HAMSCI is very open. In fact, I think most interested in extending the studies outside of North America. Today, they're working on studying Doppler shift from WWV in Colorado, and of course that signal hardly reaches. It hardly ever reaches here to Europe and elsewhere in the world. So, in a sense, one could consider if you put one of these things up, like both things, you're in essence establishing a kind of mini or micro WWV frequency and time standard setup. And having these around the world would be a tremendous contribution for radio science. Yes.
Yeah, so we see that the use of SDR uses experts and experts in analog and digital design. And this is the reason why I invited these both papers now to contribute to this SDRA. So thank you very much, Rob.
Okay.
I think there's one question from Amanda.
Yes. So thank you very much. And cool that you got the Mac working. So if we have those little devices, is there going to be any sort of effort to coordinate who is transmitting on what frequency where around the world?
It's fortunate that WSPR and 4W are really resilient to being collisions, frequency collisions, and that the WSPR decoder actually has a multipass decoding mechanism in it. So if you have two signals on the same frequency, it'll decode the stronger one, deconvolute it out, and decode the second one.
I meant more on which bands, to make sure that, so if we have a bunch of transmitters in central Germany, some of us are on 20, some of us are on 40, some of us are on 10, instead of all of us ending up on 20.
I'm sorry, I missed that. My hearing missed.
I meant more to make sure that we were distributed among the bands.
Oh, well, hopefully if you have a simultaneous multiband transmitter, you could be transmitting on multiple bands. But I think that in general, that if you don't, then right now that most of our investigations have been on 20 meters. Mm-hmm. When Joe Taylor first published and released his document about the 4W mode, which he added in, I think, JT-x 2.3, he thought it would only be useful on 2200 meters, 630, and maybe 160. So if you actually bring up JT-x, you won't be able to switch he doesn't have an entry in the frequency tables for running 4W on bands above 30. So but you can't go in and add them manually. And we have chosen to just transmit 4W on the same parts of the bands, on each band, the same place where you transmit WSPR 2 packets. And Gwynn has done an extensive study that shows that there's a very little interference between 4W and WSPR packets. So if you happen to be transmitting a 4W on a frequency where there's also a WSPR 2 transmission, you will be decoded unless that's a much stronger. I think it has to be 8 dB or something. Yeah, it has to be 8 dB stronger than your 4W signal before it will start to interfere with it. So I think that there's suggestions about using different bands for 4W, but our inclination is not. It would certainly complicate my wsprdaemon software to try to tune to have different bands for 4W than, and we also see very little reason to do so. So in general, I think Gwynn and maybe even Arnie, do you have a page someplace that shows the distribution of frequencies of transmitters across a band? Yeah, I think Gwynn did a study and found that stay away from 1500, right in the middle, 1500 hertz middle. If you get 20 or 30 hertz off of that, you're well down the Gaussian curve of transmit frequencies. So anyway, I think you don't have to worry much about conflicts between your
I
signals.
meant more, should I choose to take the 20-meter frequency or should I take the 10-meter frequency, for instance, if...
Right.
Okay.
They're all useful.
Thank you very
over,
much
we can
for
talk
the
about this afterwards.
contribution. This was a nice introduction to the use of software-defined radio in atmospheric and ionospheric research. So thank you very much to all of you. I see a lot of people not going to the meal. Thank you very much for all of them. But we have the next time at 12:30 the Ulrich Rode Award, and hopefully you are back then after a short bio break. Thank you very much to all of you for the discussion, and hopefully we see you in the afternoon when it's going more into hardware and software SDR.